Hello everyone, this is Chandimu Yanage from Cybernet Systems. Today we are going to introduce a solution that is capable of capturing the real environment using point cloud data and using it for simulation with ANSYS Discovery. If you are wondering what is 3D scanning technology, how we are going to capture it, what can ANSYS Discovery do with it, we will talk about all that in a minute. This is a quick overview of our group company as usual. Cybernet Malaysia is a fully owned subsidiary of Cybernet Systems Company Limited, headquartered in Tokyo, Japan. Established 37 years ago in 1985, our partnership with ANSYS also runs back a few decades. We have two more sales subsidiaries other than Malaysia, one in China and another one in Taiwan. If you have heard about Sigmetrix, MapleSoft, and Noisys Solutions, they are also a part of the Cybernet group. Cybernet Systems Malaysia is a channel partner of ANSYS for the countries in the ASEAN region. We are specialized in CAE and we also provide solutions for digital transformation, such as AR applications for manufacturing and industrial IoT solutions, including engineering services, training, and consultation services for all of these solutions. This content was originally created by our engineers at Cybernet Systems Japan. Simulation software used in this presentation is ANSYS Discovery. These are some of the additional resources related to the webinar topic. We have shared all of them on our website and LinkedIn prior to the webinar. Hope you have had a chance to look at all of them. If not, please do so after the webinar. The first one is a data sheet of ANSYS Discovery, and the two videos are brief introductions to ANSYS Discovery and InfoPoints. Now let's turn to our main topic, a new solution using ANSYS Discovery by utilizing point cloud data. Please write all your questions in the chat so we can send you the answers later. First of all, I would like to show you an example of a point cloud. Actually, this is the 18th floor of Cybernet head office in Tokyo, Japan. It was captured with a 3D scanner and processed with InfoPoints, which can handle large-scale point cloud data at high speeds. InfoPoints can check the data from any position, and you can take a look around using a walkthrough-like interface. Now, this is not 3D data such as solid objects and surfaces. It's made of point cloud data. In simple terms, that means billions of individual points. Since you can move around freely, it is possible to view the captured space from a position that is difficult to do so in the real space, such as looking through the ceiling to take a bird's eye view of the whole space. Not only you can see, but it's also possible to measure because each point has a coordinate value of XYZ axis. In addition, it's also possible to move across cross sections like in a CT scan. You can see vertical cross sections from wall to wall, or you can do it from ceiling to the floor. In this particular example, it took only about 2 hours to scan the entire floor and another 2 hours for data processing. It's just half a day's work. Let's talk a little bit about InfoPoints. Laser point cloud scanning has become the preferred method to capture measurements and volumetric data of large spaces for renovations, remodeling, equipment replacement, and even disaster evaluation. InfoPoints is the most powerful point cloud data processing, modeling, and analytics technology available out there to maximize the unique capabilities and performance of 3D point cloud data for engineering applications. InfoPoints is a software developed by Elysium. It captures more than 1 billion large-scale high-density point cloud data in its entirety. There are three main advantages. Number one, it's possible to capture and process the current state of equipment in a space as point cloud data to create a clean CAD model in a short time. The layout of facilities, architecture, etc. is often considered as current condition, and there are many cases where it does not necessarily match the original drawings. A worksite can be turned into a beautiful point cloud and easily convert it into 3D CAD data from there. Since large-scale data can be handled very smoothly, it's a stress-free operation. Number two, point cloud data can be used to make various virtual studies. In other words, you don't even have to go to the site. If there is a 3D scan data, it can be studied from anywhere using a PC. And number three is that the point cloud data can be converted to CAD data and used for pre-validation using simulations. For example, it's possible to confirm in advance whether any modifications such as air conditioning systems, etc., meets the specifications before starting the actual renovation work on site. InfiPoints uses the data captured by a 3D scanner to create a space out of point clouds and perform various validations using it. In addition, the processed point cloud data can be exported in different formats, which enables wide-ranging usage. Let me show one more example. This is a model of an entire factory created using point cloud data, and it's being used for a walkthrough. As you can see, it has a very detailed shapes. Colors are just beautiful and look so close to the real thing. As you pass by, you can actually see through the objects on both sides because they are not solid shapes. All the details are just a collection of billions of points. This is the digital measurement feature that I mentioned earlier. You can see that it's pretty easy to take measurements using the modeled environment. This is about how to perform 3D modeling from point cloud data. In this example, images are automatically converted from point cloud data into CAD data by extracting the details of piping inside buildings. In fact, when measuring distance, as I showed in the previous slide, you will be able to measure between the axes of the pipes. Taking another step forward, we can mix point cloud data and solidified data as shown in these images. For example, we can evaluate plans to lay new pipes or rerouting existing pipelines before actually doing it in the real environment. In addition, you can move the equipment in the original position and check the impact, or arrange new equipment as CAD data and check how they fit into the overall layout with the rest of the equipment that are already in place. This video is another good use case. When it's necessary to deliver and install new equipment, you can validate those plans by moving a CAD model along the delivery route to confirm whether there's any interference from existing equipment before rolling out new equipment physically into the actual environment. And then it's also possible to group existing equipment as point cloud data, move the group equipment data to change the layout, and of course check for interference with other facilities when moving. So whether you want to bring in new equipment, do some changes to the existing structures, or even change the current layout, these point cloud data can become really useful. Next, we are going to take a look at ANSYS Discovery and then to see how Discovery can use point cloud data for engineering simulation. Let's start by trying to understand the concept behind ANSYS Discovery. ANSYS Discovery is a designer CAE tool. It has several stages: the model stage, the explore stage, and the define stage. In the model stage, you can create, add, and edit the shape of your product and then move them to the explore stage to simulate them in real time. In discovery, the analysis results are calculated in a matter of few seconds to tens of seconds. Finally, the refine stage is a high fidelity simulation stage that enables more accurate results using ANSYS flagship solvers. You can use them seamlessly using the same user interface. The biggest advantage of ANSYS Discovery is the computational speed of the simulation. The overwhelming speed of that fundamentally overturns the conventional concept of analysis, eliminates the need to wait for a long time to obtain analysis results as we did in the past. On the top of that chart is the conventional design process. Even before the design department makes a request to the analysis teams, some preparation work is required. Then there's waiting time until the analysis is carried out and eventually the results are returned to the designer. Moreover, considering the time required for this conventional process, it's not possible to try as many variations as you would like. And the model will inevitably be something that is closer to the existing product, which is already tested and proven. It's not possible to take a very bold approach. In other words, the room to innovate is not so much. However, when you use ANSYS Discovery, the situation changes drastically. Take a look at the bottom row. The analysis results are calculated in a matter of seconds, so designers can quickly consider different variations by themselves without worrying about latency, and it's easier to test innovative designs with out-of-the-box thinking. By having a specialized analysis department to confirm the final results of the analysis, it's possible to reduce the time and effort spent by passing around tasks back and forth, and again, that makes more room for new creations. For example, fluid flow analysis can take many days just to calculate the problem. So ANSYS Discovery can be very effective for those types of analysis. This is a diagram of the design process. At the explore stage, we search for optimal results out of many possible variations. Since the calculation result can be obtained in a few seconds, this can be done in a short time. Several design options that are closer to the desired specifications will be selected at this point. Then the refine stage narrows them down a little bit, and finally an analysis specialist can narrow it down even more with high level of accuracy using ANSYS flagship solvers. You can quickly narrow down optimal product design that matches the specifications without having to spend time to go back and forth between design and analysis like we did in the past. Discovery can handle 7 types of analysis. They include structural analysis, model analysis, heat transfer and fluid analysis, including thermal fluid coupled analysis, thermal structure coupled analysis, and topology optimization. These analyses are performed using the 3D CAD interface called Discovery Modeling in ANSYS Discovery. So adding and modifying shapes, etc. can be done without having to change the GUI. Let me give you a simple example. This is a fluid simulation of water flowing in a pipe. Now this demo clip has the Japanese GUI because originally it was created by our engineers in Japan. But of course, ANSYS Discovery comes with English GUI. Now there is a lid-like shield at the top of the pipe. We moved it into the pipe using the CAD command move. And when you move, just update the data and you will see that the result of the simulation changes instantly. Let's move the lid diagonally. By updating the data in the same way, you can check the flow results instantly. As you see in this video, you can get results right after you change geometry. If you're familiar with fluid flow analysis, you know that it's almost impossible to obtain results at such speeds with conventional fluid flow analysis. In the same way, you can get fast results for other analysis types as well. Now, by combining these two softwares, we introduce a new solution. With InfiPoints, which can handle billions of point cloud data without much difficulty, and Ansys Discovery, which allows real-time simulations, you can instantly verify different scenarios of the real environment. I think that many people can use it to solve many worksite related challenges. For example, if you are considering to replace or install new equipment, making changes made to the existing layout, etc., you can quickly check whether there is enough room in the passage to carry the equipment around. How about rerouting piping when introducing new equipment or replacing the existing ones? How does indoor airflow change due to this kind of modifications in structure or layout? It's possible to examine that type of things with the data of the actual space itself. And if you are a manufacturer, you can check your product by placing them in the customer's environment. This way, the product design can be easily improved or customized to fit the customer requirement using simulation. Finally, this video is an example of an air conditioning simulation inside a Japanese barbecue shop that actually exists in Hamamatsu, Japan. One room that is separated by a partition was captured with a 3D scanner. You can also import that data on the spot and check it with InfiPoints. Then we simulated what has been done by 3D modeling, the point cloud, and discovery. You can see that smoke comes out of the small Japanese charcoal grill called shichirin and is sucked into the duct. If you simulate the breath exhaled by people sitting at the table, you can see how it is also sucked into the duct. For easy understanding, breath is represented as particles. By measuring the actual space like this and simulating it with digitized data, it's possible to verify quantitatively and scientifically rather than speculating or designing based on assumptions. With this, we have come to the end of this presentation. I hope you found it interesting. We will reply to all of your questions after the webinar by email. If there's anyone who could not drop their questions in the chat, please send an email to information@cybernet.asia. If you have any questions about the analysis solutions that we presented today, please feel free to reach out to our team. You can call us, send an inquiry using the web form on our website, www.cybernet.asia, or again, you can send an email to information@cybernet.asia. Our team will provide you with all the additional information, and they can even arrange a demonstration if you are looking for this kind of a solution. Please stay tuned to our social media channels and the newsletter for more details about upcoming webinar. Thank you and stay safe.